Yeah, hi everyone, welcome to PrepFusion. So we need to study about random variables now. We have been studying about probability. So probability is completed. Now we will study about random variables. Okay, so complete concept of probability will be used here. Now sir, before starting the random variables, in this video only we will start random variable. But before that there is some prerequisite. There are some prerequisites that you need to study. So it is like a mathematical prerequisite. Some basic mathematics we are going to study. Okay, so it will be more like calculus. We need to study about some functions and some different kind of functions, some differentiation, integration, all these things we need to study. Okay, so for the next 40-50 minutes we will study these basic prerequisite, and after that we will get started with the random variable. Okay, so let's get started. What is given? You are given a graph of fx. You need to draw the graph of f of x plus 1 and f of x minus 2. Can you draw these graphs? Graph of fx is given. You need to draw the graph of f of x plus 1 and f of x minus 2. So let's get started. What we need to draw? First we need to draw f of x plus 1. So let's try thinking about f of x plus 1. Let's assume f of x plus 1 as gx. Okay, I'm saying f of x plus 1 is nothing but gx. Can you let me know what will be the value of g of 1? Or can you let me know what will be the value of g of 0? So g of 0 will be nothing but f of 1. So g of 0 will be nothing but f of 1, that will be 3. Can you let me know what will be the value of g of 1? So g of 1 will be nothing but f of 2. G of 1 will be nothing but f of 2, which is 0. Can you let me know what will be g of minus 1? G of minus 1 will be nothing but, sir, here you will put minus 1, so it will be f of 0. So the value will be 3. So basically what you can see here is that what will be g of minus 3? Can you let me know what will be g of minus 3? So g of minus 3 will be nothing but f of minus 2. Right? Do you understand this point? So when it comes to gx, minus 3 is equivalent to minus 2 of fx. Minus 2 will be equivalent to minus 1 of fx. 0 will be minus 1 will be equivalent to 0 of fx, and 1 will be equivalent to 0 will be equivalent to 1, 1 will be equivalent to 2, and what will be the value of g of 2? G of 2 will be equals to g of 3. So can you draw the graph of gx now? Can you draw the graph of gx? Sir, minus 2 will be replaced with minus 3. Minus 1 will be replaced with minus 2. 0 will be replaced with minus 1. That means, sir, minus 2 will be going towards minus 3. Minus 1 will be going towards minus 2. 0 will be going towards minus 1. That means this particular graph, when you are drawing f of x plus 1, this particular graph will be shifted by 1 towards the left hand side. Left shifting would be there. Are you able to understand this point? The same graph will be shifted towards the left hand side. Is that understandable to you or not? So how the graph would look like? The graph would look somewhat like this, that the graph will be shifted. You are drawing the graph of f of x plus 1. So the whole graph will be shifted by 1. So the graph would look somewhat like this. F of x plus 1. Okay, so this value will be minus 3, this value will be minus 2, this value will be 0, and this value will be 1, and in between the value will be 1 only. Here also the value will be 1 only. Okay, so whatever that was happening at minus 1, that has happened as minus 2. Whatever that was happening at minus 2, the same has happened as at minus 3. Whatever that was happening at plus 1, that is happening at 0, and whatever that was happening at 2, that is happening at 1. So this will be the graph of f of x plus 1. So what did you notice? You noticed one thing, that when there is a f of x plus a, where a is a positive value, then the graph is shifted towards the left hand side. Graph is shifted towards the left hand side. Graph is shifted towards the left hand side, or you can say leftwards, towards the left hand side. So if it is positive, then it will be shifted towards the left hand side, and if it is negative, then what will happen? And if a is negative, f of x plus a, if a is negative, then what will happen? The graph will be shifted towards the right hand side. Graph is shifted rightward. What does that mean? Can you draw the graph of f of x plus 2 now? Not x plus 2, sorry, f of x minus 2. Can you draw the graph of f of x minus 2? For sure, sir, I can draw the graph of f of x minus 2. The graph will be shifted by 2. The graph will be shifted by 2 towards the right hand side. So this is known as right shifting, this is known as left shifting. If there is positive, then left shifting. If there is negative, then right shifting. So it will be shifted by 2. So minus 2 will come to 0, minus 1 will come to plus 1, 0 will come to plus 2, 1 will come to 3, 2 will come to 4. So how the graph would look like? The graph would look somewhat like this. The graph will be shifted. This is how the graph would look. Say yes or no. Is that understandable to you? Absolutely. So sir, this value was 2, this 2 has become 4. Sir, this value was 1, this 1 has become 3. Sir, this value was 0, sir, this 0 has become 2. Sir, this value was minus 1, this minus 1 has become plus 1. And sir, this value was minus 2, that has become 0. So this is the graph of f of x minus 2, f of x plus 1. Similarly, I can draw a lot of graphs as well. Like, let's just say, let's try drawing the graph of f of x plus 1.5. f of x plus 1.5. Can you draw the graph of f of x plus 1.5? Can you draw this graph? So sir, fx will be shifted by 1.5. 1.5 towards the plus is there, no? Plus is there. F of x plus 1.5. Plus 1.5. That means it will be shifted by 1.5 towards the left hand side. So minus 2 will go to minus 3.5. This will go to minus 2.5. 0 will go to minus 1.5. And 2 will go to 0.5. So how the graph would look like? So this is 1. 1 will go to, it will be shifted by 1.5. So 1 will go to minus 0.5. So 1 will go to minus 0.5. So the graph would look somewhat like this. This is how the graph would look. So graph will be shifted by 1.5 towards the left hand side. So 2 will become plus 0.5. 2 will become 0.5 because 2 minus 1.5. It is shifted by 1.5, right? So this will become 0.5. Now this was 1. This value was 1. This value was 1. So at 1, 1 will become minus 0.5. So this value will become minus 0.5. Minus 0.5 or minus 1 by 2, you can say. This will be plus 1 by 2. And what about this? What about this value? So minus 1 will become minus 2.5. Minus 1 will become minus 2.5, which is minus 5 by 2. And this minus 2 will become minus 3 minus 1 by 2. That will become, sorry, minus 3 minus 3, minus 2 minus 3 by 2. So that will become minus 7 by 2. So this will become minus 3.5, right? So it will become minus 7 by 2. All these gaps will remain same. So what is the gap here? The gap is 1 only here, right? What is the gap between these two guys? The gap is between these two guys is 2. And what is this gap? This gap is 1. And what is the complete length? This complete length was 4. So all these are remaining same. What is the complete length? This complete length is 4 only. What is the gap between these two guys? That is 1 only. What is the gap between these two guys? That is 2 only. And what is the gap here? That is 1 only. So these gaps and all will remain same. 1, 2, 1, complete length is 4. All these will remain same. Right? So this is how we can draw the graph. Similarly, you can draw the graph of f of x minus 1.5 as well. Okay, minus 1.5 means the graph will be shifted by 1.5 towards the right hand side. So similarly, you can draw those graphs as well. Understandable? So all these are crystal clear. Everything is absolutely understandable. So can I draw the graph of f of, let's draw one more graph, f of x minus 1.5. F of x minus 1.5. So this is how the graph would go. You can think on your own and you can draw the graph. Okay, I have already given the scenarios that 2 will become plus 3.5, 2 will become plus 3.5, or you can say plus 7 by 2. 1 will become 1 plus 3 by 2 will be 5 by 2. Now this was minus 1. Minus 1 will become minus 1 plus 3 by 2. That will become 1 by 2. Right? And what will be this? This will be minus 1 by 2. and in between there will be another point. All these are fine. So gap here is 1, here the gap is 2, here is 1, and complete length is 4. So everything else will remain the same. So this is the graph of f of x minus 1.5. So this is how you can draw the graph of shifting. F of x plus a also you can draw. F of x plus a, where a is positive you can draw, where a is negative, that graph also you can draw. So both of the graphs you are able to draw. Understandable? Let's go to the next thing. So some standard function we are going to study. Do you already know about the mode function? I hope you already know about the mode function. What is the meaning of mode function? Sir, mode function is nothing but a mode of x, and it will be opening as plus x for x greater than 0 and minus x for x less than 0, right? And how the graph is made? The graph of mode of x, this we have already studied in the calculus. Okay, in calculus we have already studied. So this is the graph of mode of x, right? You can call it fx as of now. So for x greater than 0 you need to draw the graph of x, and for x less than 0 you need to draw the graph of minus x. So the graph of minus x goes like this, but it is something you need to make for x less than 0 only. That means for x less than 0 you will follow the graph of minus x. So this graph is minus x, this graph is plus x. So this is your fx equals to minus x for x less than 0 and fx equals to plus x for x greater than 0. This is the scenario. This is the graph of mode function. Okay. Now there is something which you did not study, that is known as step function. What is the meaning of step function? So step function is represented by u of x. Okay, it is represented by ux. This is the way of representing. Like, what was the way of representing here? Sir, two vertical lines. So mode of x. What is the way of representing step function? Step function will be represented by u of x. So that is equals to 1 for x greater than 0, 0 for x less than 0. So what I mean to say, can I draw the graph of ux? Absolutely, sir, you can draw the graph of ux. Sir, your fx is nothing but ux. So can I draw its graph? Absolutely, sir, you can draw its graph. Sir, for x less than 0 it will be equals to 0 only. For x less than 0 it will be equals to 0 only. And sir, for x greater than 0 it will be equals to 1. For x greater than 0 it will be equals to 1. Sir, what about at x equals to 0? At x equals to 0 it is not defined. It is not defined at x equals to 0. Not defined. Step function is not defined at x equals to 0. So what will be the value? That we don't know. So this is how we draw in mathematics. This is how we will draw the graph of step function in mathematics. That, sir, for x less than 0 the value is 0. For x greater than 0 the value is 1. But in the examination or in the textbook as well, what you would find, they would draw the graph in this way. That, sir, here the value is 0, 0, 0. Then the value is becoming 1. But sir, at the transition is happening at x equals to 0. I don't know the value. So how they will show that you are going from 0 to 1. You are going from 0 to 1. If someone asks me what is the value of f of 0 here, f of 0, someone asks me f of 0, I will say I don't know. F of 0 I don't know. But if someone asks me what is the value of f of 0 plus, what is the meaning of 0 plus? Sir, this is 0. 0 plus means just ahead of 0. And what is the meaning of 0 minus? Just before 0. So what is the meaning of f of 0 plus? That is, sir, 1. That is 1. And what is the meaning of f of 0 minus? That is 0. So in some textbook what they do is that they say that f of 0 will be average of both of them. Average of both of them. Average of both of them. So 1 plus 0 divided by 2, that would be 1 by 2. So f of 0 is 1 by 2. This is what they say. But actually, again, it is not a very good way of defining the function. Okay, it is not a very good way. This is a very crude way. So step function is not defined at x equals to 0. But sir, how will you draw it? I will draw in this manner. The value is 0, 0, 0, 0. Then I will show a vertical line and I am going to 1. In mathematics, how we used to show? This is how we used to show. That no vertical line we used to make. But now, in this lecture, in random variable, we will make a vertical line. This is how we will show it. Even in the examination, this has come a lot of times, and surely in the textbook as well, you will find in this way. So this vertical line means we don't know the value here. Or you can simply take the average. The value could be defined as 1 by 2. Vertical line means the value of f of 0 could be defined as 1 by 2. This you will take only if it is required. Otherwise, you will say not defined. But who knows, there is some question, sir, there I require the value of f of 0, sir, what value I take now? So neither you will take 1 nor you will take 0, you will take the average of both of them, that will be 1 by 2. When it is required. Otherwise, you will say not defined, I don't know what is the value. There is a sudden jump. Okay. And is it a continuous function here? Is it a continuous function? No, it is not continuous, right? Do you know the meaning of continuous function? Left hand limit, right hand limit. Although if you don't know, we will study those topics in this lecture only. Don't worry, but already in calculus we have studied. So if I talk about the right hand limit, the value is 1. If I talk about the left hand limit, the value is 0. That means both of these values are not same. If they are not same, that means it is discontinuous at x equals to 0. So if it is discontinuous at x equals to 0, then how the value could be defined? Okay, so it is discontinuous. Understandable? So this is known as step function. Okay, now there is another function which is known as ramp function. So how the step function is represented? Sir, step function is represented by ux. The value of ux is defined as, sir, it will be 1 for x greater than 0 and it will be 0 for x less than 0. This is how your step function is defined. Now how the ramp function is defined? So sir, ramp function is represented by rx. Okay, and why it is known as step? It is a step, no? You are going from 0 0 0, then you are taking a step to 1, right? So it is like a step, you are taking a step. It is like a staircase, no? It is like a staircase, right? It is one of the stair. So you are taking a step. So that's why it is known as step function. What do you mean by ramp function? Ramp function is represented by rx. So it is equals to x for x greater than equals to 0 and it is 0 for x less than 0. Is that understandable to you? So what kind of graph would be there? Can you draw the graph on your own? You need to draw the graph of a ramp function. Can you draw it on your own? You should be able to draw on your own only. What you need to draw? You need to draw the graph of 0 for x less than 0. You need to draw the graph of 0 for x less than 0. For x less than 0, the graph is 0. For x greater than 0, the graph should be equals to x. For x greater than 0, fx should be equals to x. So for x greater than 0, fx should be equals to x. And for x less than 0, fx should be equals to 0. Okay, this is the scenario. What is the slope here? What is the slope here? I hope you know the basic meaning of slope. What is the slope here? Slope is 1. Okay, what is the slope of a graph fx equals to x? That is 1 only, no? Y equals to mx plus c. So c is 0. What is the slope? M value is 1. So y equals to x. So slope is 1. The slope is 1. Understandable? So this is your ramp function. Understandable? So what is the meaning of ramp function? Ramp function means it will be defined for x greater than 0, fx will be equals to x. For x less than 0, fx will be equals to 0. Now next question. Can I write down rx as xux? Xux. If you think closely, then you will say, yes sir, x into ux. Just think about it. What is the graph of x? This is the graph of x. And what is the graph of ux? Sir, this is the graph of ux. You need to multiply both of the graphs. You need to multiply both of the graphs. So sir, any value multiply with 0 will be 0 only. And sir, any value here, what is the value? X. Here also the value is x only. X multiply with 0 will be 0 only. X multiply with 1 will be x only. Any value multiply with 1 will be x only. So what kind of graph you are getting? The same graph which is rx only. So rx could be written as x into ux. So very important, this you need to remember. Rx could be written as x into ux. Is that understandable to you? Okay. Because again you can see here, what could be x into ux? What is ux? Ux is sir 1 and 0. Two values it can take for x greater than 0, for x less than 0. So for x greater than 0, x will be multiplied with 1 only. And for x less than 0, x will be multiplied with 0. So are we getting the same definition? Yes sir, we are getting the same definition only. Is that understandable to you? So rx could be written as x into ux. So this is the meaning of ramp function. Here we have studied about a step function. Here we have studied about ramp function. And here everything is defined. What is the slope here? Slope is 0. So is it continuous? Is it continuous here? Yes. Is it differentiable here? No. Do you know the meaning of differentiability? Sir, here the slope is 0. And sir, here the slope is 1. That means there is a sudden change in the slope. There is a sharp transition. There is a sharp transition. So all these things we have studied in the calculus. Okay. So there is a sharp transition here. There is a sharp transition. At this point, at x equals to 0, there is a sharp transition. Before that, the slope was 0. And after that, the slope was 1. So there is a sharp transition. If there was a smooth transition, then it would have been differentiable. But sir, since there is a sharp transition, it is not a differentiable graph. It is a non-differentiable graph. Okay. So it is not differentiable, but it is continuous. So all these things we have already seen in the calculus. We are just revising now. Okay. So step function we have studied. Ramp function also we have studied. Now let's keep it here. Let's keep this one here. Next, let's define a function. I am defining a function fx. Okay. Which is defined between minus a to a. So value of fx is 1 by 2a. Value of fx is 1 by 2a. when x is between minus a to a. Okay, and sir, what is the meaning of this sharp transition? What is the meaning of this sharp transition? That means the value is not defined at x equals to a. The value is not defined at x equals to minus a. These values are not even defined here. That means between minus a to a, the value is 1 by 2a. Here the values are not even defined. And if x is greater than a, or if x is less than minus a, greater than a or less than minus a, then the value is 0. This is your function fx. Function fx is, it is between minus a to a, the value is 1 by 2a. For greater than a, for less than minus a, the value is 0. Sir, there is a sharp transition, that means the value are not defined here. I don't know what is the value here. I don't know what is the value here. Okay. If someone asks you in the worst possible case, if you need to write down, sir, what is the value of fx at x equals to a, then what you will do? You will take the average 1 by 2a plus next value is 0 divided by 2. Answer will be 1 by 4. Similarly here as well. Okay, so you will take the average. In the worst case, if you need the value of fx at x equals to a, in some question, let's just say I need the value of fx at x equals to a, then I will take the average. Otherwise I will say not defined. Understandable? Now what I am doing, let x equals to 1 by 2. What I am doing, I am keeping at x equals to 1 by 2. So if I keep, sorry, not x equals to 1 by 2, I am keeping a equals to 1 by 2. So if I keep a equals to 1 by 2, then what kind of graph I will be getting? If I keep a equals to 1 by 2, then what kind of graph I will be getting? Sir, I will be getting this kind of graph. If a is 1 by 2. If a is 1 by 2. Then sir, here a equals to 1 by 2, if you will put, then what you will be getting, this value will become 1. Now let me know one thing, what is the area? Here if I ask you minus infinity to infinity fx dot dx, what is the area for this graph? What is the area for this graph? Sir, this length is 2a. 2a multiply with, this length is 2a, no? So sir, 2a multiply with 1 by 2a. So area is 1. Here what is the area? Everything will make sense, just have some patience. Minus infinity to infinity fx dot dx. Minus infinity to infinity fx dot dx, that means you are supposed to calculate the whole area. What is the whole area here? Sir, minus 1 by 2 to 1 by 2, this length is 1. 1 multiply with 1, the area is 1 only. Now what I am doing is that I am keeping a equals to 1 by 4. What I am doing now, I am keeping a equals to 1 by 4 this time. So if I keep a equals to 1 by 4, then what will happen? Equals to, okay. Let's keep a equals to 1 by 4. So what will happen now? If I keep a equals to 1 by 4, then what will happen is that, sir, this will become minus 1 by 4. This will become 1 by 4. And sir, here if I put 1 by 4, this will become 2. 1 by 2 multiply with 1 by 4, sir, 4 by 2, that will be 2. So do you notice one thing, what I am doing? I am making sure that area always remains 1. Again, if I ask you what is the area, I am making sure that area always remains 1. What is the area? Area is 1. Always I am making sure one thing, the area is 1. Area is 1. Now did you notice one thing, that when I reduced this width, when this width was 1, now I have made the width 1 by 2. So when I am reducing this width, the length is going upper. Here length means this length I am talking about. This length has become 2. Initially this length was 1. If I need to make sure that area is 1 only, so if I reduce the width, the length will become larger. If I reduce the width even more, now a equals to 1 by 8 I will put. What I am putting? A equals to 1 by 8 I am putting. A equals to 1 by 8 I am putting. So a equals to 1 by 8. So this is minus 1 by 8 and this is 1 by 8. Now what is my length now? Or you can say width. Here what was the width? Width was 1 by 2. Now what is the width? Sir, 1 by 8 plus 1 by 8, the width is 2 by 8. That means width is 1 by 4 now. So to keep the area same, what length I need to pick? The length has to be 4. The length has to be 4. So this point will be 4. So what will be the area? The area will be, sir, here the area will be minus infinity to infinity fx dot dx. Area is 1 by 4 into 4, area is 1. But you are noticing one thing. What you are noticing? You are noticing one thing, that sir, if the width is going lesser, initially the width was 1, then 1 by 2, then 1 by 8. So as the width is going lesser, the length is increasing. As the width is going lesser, the length is increasing from 1 to 2, then to 4. Now what if I make a tending to 0? So this guy will come to 0 and this guy will also come to 0. Then what will happen? If a tends to 0, then the graph would look somewhat like this. If a tends to 0, the graph would look somewhat like this. That, sir, the width has become very small. A tending to 0, width has become very small. Width has become very small. So length will become very, very large. The length will become very, very large. So just let me know one thing. If your width is tending to 0, if your width is tending to 0, if this width is tending to 0, then your length will tend to what? If this is tending to 0, then your length will tend to infinity. Are you able to understand this point? But again, I am making sure one thing, that what is the area? Area always remains 1 only. So this is the graph I have made, but the area always remains 1 only. Area always remains 1 only. 1 only. Always making sure that area is 1, but length is increasing drastically. And this is happening at x equals to 0 only. Because near 0 only, no? A is tending to 0, minus a is also tending to 0, a is also tending to 0. So everything is happening at x equals to 0 only. So at x equals to 0, you can see one thing, that, sir, I am getting an infinite amplitude, but the area of the graph remains 1. So from here, the definition of impulse function will come into action. So, sir, impulse function is shown by delta x. And that is, sir, it will give you infinite amplitude at x equals to 0. Infinite amplitude, what this is? This is your amplitude. It will give you infinite amplitude at x equals to 0. And, sir, otherwise, apart from x, this is otherwise, apart from x equals to 0. That means if x is not equals to 0, if x is not equals to 0. So if x is not equals to 0, what is the value here? 0 only. Like, what is the value here? The value is 0 only, no? What is the value? Value is 0 only. So if x is not equals to 0, then the value is 0 only. But if x is equals to 0, then the value is infinity. So if x equals to 0, then amplitude is infinity. And if x is not equals to 0, then the value is 0. So this is your delta function. This is how the delta function is defined. But another important thing is that we are making sure one thing, the area always remains 1. The area always remains 1. The area always remains 1. Is that understandable to you? So this is the definition of impulse function. If I would have started from here, then you would not understand what we are doing. Okay, but this is just a concept building of impulse function. That how we started. We took a box, area was 1. Then we started reducing the width. The width has become 1. Then length is 1. Then we reduce it more. The length has become, the width has become 1 by 2. The length is 2. The width has become 1 by 4. The length is 4. If the width becomes 1 by 8, then the length will be 8. If the width becomes 1 by 16, the length will be 16. And if width becomes 0, then length will become infinity. Isn't it like the reciprocal? 1 by 8 reciprocal of this reciprocal. So if width becomes 0, then the length will become infinity. Right? That means near at x equals to 0. At x equals to 0, it will show infinite amplitude. But apart from x equals to 0, it will show 0 amplitude. But area always remains 1. So how do you show it in the graph? What is the way of showing it? So the way of showing it somewhat like this. First you make the axis. This is your x. Fx. You make the axis. And, sir, I show it like this kind of arrow. This is how it is shown. And here what I will write down? I will write down 1. So what this 1 is representing? This 1 is representing the area, not the amplitude. Area, not the amplitude. And what this arrow is representing? This arrow. What this arrow is representing? This arrow is representing that amplitude is going towards infinity. That means amplitude is infinity. Amplitude is infinity. This arrow is representing that amplitude is infinity, and this 1 is representing, what this 1 is representing? This 1 is representing that it is having area of 1. Let's just say 2 impulses are made. Here 1 is written, here 2 is written. And let's just say it is your x equals to 0, this is your x equals to 1. So if I ask you, what is the amplitude at x equals to 0? What is the amplitude at x equals to 0? You will say infinity. What is the amplitude at x equals to 1? You will say also infinity. But what is the area near to x equals to 0? If I ask you what is the area near to x equals to 0, that means this is how I can ask you. From 0 minus to 0 plus, what is the area of the graph? You will say, sir, area near to x equals to 0 is 1. And what is the area near to x equals to 1? That means from 1 minus to 1 plus. Here I am saying 0 minus to 0 plus. Similarly, 1 minus to 1 plus. What is the area? Sir, the area of the graph is 2. Okay, so the height of this arrow is representing the area. It will always represent the area. What it would represent? It would always represent the area. Understandable? But this arrow is made. No, if this arrow is made, then by default the amplitude is infinity always. Is that understandable to you? So this is how you show impulse function. So this is the complete concept of impulse function. Is that understandable? Surely, sir, completely understandable. Impulse function means, sir, amplitude at x equals to 0 will be infinity, otherwise the amplitude will be 0. Along with that, sir, area would always remain 1. Here I have written the area I am taking from minus infinity to plus infinity. From minus infinity to plus infinity. Now, if I give you this graph and I ask you one question, what is the area from minus infinity to minus 1? What is the area? From minus infinity to minus 1. Sir, from minus infinity to minus 1, this is my minus 1, no? So, sir, from minus infinity to minus 1, there is nothing. The graph is 0 only. There is nothing. So, sir, between minus infinity to minus 1, the fx is 0 only. So, what will be the answer? Answer will be 0 only. If I ask you, what is the area from 1 to infinity? What is the area from 1 to infinity? Sir, area from 1 to infinity, 1 to infinity, 1 to infinity. Sir, there is nothing. So, it will be 0 only. And what is fx? Fx is nothing but delta x only. Fx is nothing but delta x only. So, this is 0. This is 0. From 1 to infinity also it is 0. If I ask you, what is the area between minus infinity to 0 minus, minus infinity to 0 minus, delta x dot dx. What will be the answer? 0 minus will be somewhere here. So, just before 0, the impulse is there exactly at x equals to 0. Just before 0, what is the amplitude? That is 0 only. So, sir, from minus infinity to 0 minus, there is no amplitude. From minus infinity to 0 minus, sir, there is no amplitude. So, answer will be 0. From 0 plus to infinity, what will be the answer? From 0 plus to infinity. From 0 plus to infinity, what will be the answer? Sir, from 0 plus, this is my 0 plus. Sir, from 0 plus to infinity also there is no amplitude. Answer will be 0 only. But if I ask you from 0 minus to, I am asking you one question, from 0 minus to 0 plus, what is delta x dot dx? What will be your answer? So that would be equals to 1 only. Why is that so? Because, sir, from 0 minus to 0 plus, I will get my impulse. And what is the area of this impulse? That is 1 only. Is that understandable to you or not? Is everything understandable to you or not? All of these are making sense or not? Impulse is defined only at x equals to 0. Impulse is defined only at x equals to 0. Impulse function delta x is defined only at x equals to 0. And that will show infinite amplitude and the area would be 1. So if you take the integration from minus infinity to infinity, then also, sir, there is one impulse. Or if you take the integration from 0 minus to 0 plus, then also, sir, there is one impulse. Area would be 1 only. Is that understandable to you? So if you take from minus infinity to infinity, or you take from 0 minus to 0 plus, the area would be 1 only. So we have studied 3 kind of function. First one was step. What is the meaning of step function? So for x less than 0 it is 0, for x greater than 0 it is 1. What is the meaning of ramp function? So ramp function is for x less than 0 it is 0, for x greater than 0 it is equals to x. And then we studied about impulse function. What is the meaning of impulse function? So for x equals to 0 it is showing infinite amplitude, for x apart from 0 it is showing 0 amplitude. And, sir, area is 1. That's it. These are the 3 functions. Just look at the screen very carefully. This we have studied. Then we understood the meaning of f of 0. Then we studied this, understood the meaning that Rx could be written as x ux. And then we studied about this particular function, impulse function. 3 functions we have studied. That's it. Okay, these 3 functions was the matter of concern. Now you need to draw the graph of 5 ux minus 2 ux minus 3 delta x minus 2 delta x plus 1. These 4 graphs you need to draw versus x. Versus x. Okay, try drawing these graphs. First graph, 5ux. First one. Let's just say it is f1x. I need to draw 5ux. How will I draw? Sir, first of all, I will draw 5u. First of all, I will draw the graph of ux. Do I know how the graph of ux looks like? Yes, sir. 0 and then 1. This is the graph of ux. Amplitude is 1. Amplitude is 1. Now, what is happening? Amplitude is multiplied with 5. Let's just say I need to, let's just say I know the graph, I know this graph. Here the amplitude is 1. If I multiply this graph, this is your fx. Now if I multiply fx with 5, then what kind of graph you will be getting? The same graph, just 1 will be multiplied with 5. That's it. 0 will also be multiplied with 5. 0 into 5 will be 0 only. 0 will also be multiplied with 5. 0 into 5 will be 0 only. 1 will also be multiplied with 5. 1 into 5 will be 5 only. So this is how the graph would look like. So similarly, ux, this is the graph of ux. Now ux is multiplied with 5. Ux is multiplied with 5. So this value will become 5. That's it. So So this is your graph of f1x, or you can say 5ux. Basically, how the 5ux will be defined? So 5ux will be defined in this way, that it will throw the value 5 for x greater than 0, and it will throw the value 0 for x less than 0. If only ux was there, that means it was throwing value 1. If 5ux is there, that means it is throwing value 5. That's it. This is the meaning of 5ux. Secondly, f2x, you need to define minus 2ux plus 1. So first of all, forget about this minus 2. You let me know the graph of u of x plus 1. So sir, this is the graph of ux. This is the graph of ux. What will be the graph of u of x plus 1? U of x plus 1. U of x plus 1. What does that mean? Plus 1 means it will be shifted by 1 towards the left hand side. So u of x plus 1, the graph will be like this. U of x plus 1, the graph will be like this. Right? And now this graph, what is the value here? The value will be 1. It will be just shifted by 1. U of x plus 1. Plus 1 means first page. Plus 1. F of x plus 1. That means shifted by 1 on the left hand side. Shifted by 1 on the left hand side. So similarly, here also shifted by 1 on the left hand side. Now this 1 will be multiplied with minus 2. You need to multiply this 1 with minus 2. So 1 will become minus 2. So here the value was 1. This value will become minus 2. So this is how the graph would look like. So how the graph would look like? The graph would look somewhat like this. That at a minus 1, so for x less than minus 1, the value is 0. The value is 0. And at minus 1, the value has become minus 2. This is your f2x versus x. Okay. There you go. This is the scenario. So how you can define it? Minus 2 u of x plus 1. So it will be equals to minus 2 for x greater than minus 1, and it will be equals to 0 for x less than 0. Is that understandable to you? There could be other way of defining, like let's just say, how do I define u of x? So I define u of x as u of x will be 1 for x greater than 0, and it will be 0 for x less than 0, right? This is how I define it. This is how I define u of x. Now what about u of x plus 1? Sir, u of x plus 1 will be equals to 1. Sir, where constant value is there, here constant value 1 is there, here constant value 0 is there. Sir, in place of x, I am supposed to put x plus 1. In place of x, I am supposed to put x plus 1. Sir, in place of x, I am supposed to put x plus 1. So x plus 1 greater than 0, that means x would be greater than minus 1. X plus 1 greater than 0 means x would be greater than minus 1. X plus 1 less than 0 means x would be less than minus 1. X plus 1, x would be less than minus 1. There you go. So this is how u of x plus 1 would be defined. And if I multiply with minus 2, then sir, the amplitude will be multiplied with minus 2. So this value will also be multiplied with minus 2. This value will be multiplied with 1 will be multiplied with minus 2. That will be minus 2. 0 multiplied with minus 2 will be 0. There you go. So minus 2 u of x plus 1 will be equals to minus 2 for x greater than minus 1, and it will be 0 for x less than minus 1. This is how we can draw the graph, or this is how we can define it. So everything we know the shifting as well, and this is also how we can draw the graph. Now next we need to draw 3 delta x. What is the meaning of 3 delta x? Next we need to draw 3 delta x. 3 delta x. How delta x is defined? So delta x will show, if x equals to 0, it will show infinite amplitude. If x is not equals to 0, it will show 0 amplitude. If you multiply 3 here, then what will happen? 3 into infinity will also be infinity only. And 0 into 3 will also be 0 only. So no change would be there, no? So it will show infinite amplitude only. It will show 0 amplitude only. But you know one thing, that minus infinity to infinity, delta x dx would show the area to be 1. But here in place of delta x, I need to put 3 delta x now. So how much area it would show? On both of the side you are multiplying with 3. So it will show the area equals to 3. So what I will do, sir, again the same way I will draw the graph. The graph would be drawn in the same way. That sir, 3 delta x I need to draw. So this is how I will draw the graph. That infinite amplitude is there, that means I will show the arrow. But near the arrow, what I will write down? Will I write down 1 or 3? I will write down 3, because 3 is representing the area. So here I will write down 3. So this is the graph of f3x versus x. Is that understandable to you? So area is 3. Understandable? So area is 3, and this is how you will show the arrow. You are showing the arrow means amplitude is infinity, but this 3 is representing the area. Is that understandable too? So this is the impulse of area 3. What is the language I will be using? Impulse of area 3. Impulse of area 3. Understandable? Okay. Next, f4x. What is that? Minus 2 delta x plus 1. Minus 2 delta x plus 1. So, first of all, can you draw the graph of delta x? Yes, sir, this is the graph of delta x. Now, can you draw the graph of delta x plus 1? This is the graph of delta x. Delta x plus 1. What will be the graph of delta x plus 1? Sir, x plus 1. What does that mean? That means the graph will be shifted leftwards, no? X plus 1. X plus 1. So, graph will be shifted leftwards by 1. So, this 0 will become minus 1. So, what is the amplitude? Amplitude will be infinity. Amplitude will be infinity only. But here, what is the area? Area is 1. But now, how much area you will get? Here, the area was 1, but now area is multiplied with minus 2. So, what will be the area now? The area will become minus 2, no? The area will become minus 2 now. So, how will you show the minus 2 area? That means you will show the impulse in the downward direction. So, this is how you will show the impulse. How the impulse will be shown? You know that, sir, impulse will be there at x equals to minus 1. Impulse will be there at x equals to minus 1. But, sir, area is minus 2 this time. That's why I will show it downward. So, here I will write down area is minus 2. This is how I will show f4 of x versus x. Is that understandable to you? Or you can define it as well. How will you define? As a delta x I define in this way. That this is how I define, sir, delta x. That it will show infinite amplitude and it will show 0 amplitude when x equals to 0 and when x is not equals to 0. So, in place of x, what we are putting? X plus 1. In place of x, what we are putting? X plus 1. Right? So, in place of x, we are putting x plus 1. So, in place of x, let's put x plus 1. That is equals to 0 and x plus 1 not equals to 0. So, what you will be getting? X equals to minus 1, x equals to not minus 1. So, x equals to minus 1. When x is minus 1, then you are getting infinite area. When x is not equals to minus 1, then you are getting, when x equals to minus 1, you are getting infinite amplitude, not area. And when x is not equals to minus 1, then you are getting 0. Okay. Now, that is being multiplied with minus 2. That is being multiplied with minus 2. So, infinite multiply with minus 2. Infinite multiply with minus 2. That will be minus infinity, no? Infinite multiply with minus 2, it will become minus infinity. And 0 multiply with minus 2 will be 0 only. So, when this is multiplied with minus 2, so this will become minus infinity. So, you are getting the amplitude minus infinity. That means you are getting the amplitude in the negative direction at x equals to minus 1. Getting the amplitude in the negative direction. And what will be the area? Because, sir, I need to show the area as well. So, sir, I know that minus infinity to infinity delta of x plus 1 dot dx, sir, this will throw area to be 1 only. Like basically, if I say, I know the answer of this, sir. I know the answer of this. I know the answer of this. So, this answer is 1. So, in place of x, if I put x plus 1, will the answer change? In place of x, so this is basics of integration. No, in place of x, if I put x plus 1, will the answer change? No. Like basically, I am saying that minus infinity to infinity, f of x dot dx is equals to 3, let's just say. Then minus infinity to infinity, what will be f of x plus 2 dot dx? That will also be 3 only, no? Let's keep f of x plus 2 as t. Then dx would be equals to dt. So, f of t dot dt. And how the limit would go? If x is minus infinity, then t will also be minus infinity. If x is infinity, then t will also be infinity. So, minus infinity to infinity, f of t dot dt. What is that? That is equals to 3 only. And now in place of t, you can put x. So, f of x dot dx. So, it is 3 only, no? It is very pretty obvious. So, minus infinity to infinity, delta of x plus 1 dot dx will be 1 only. And if you multiply it with, this with minus 2, if you multiply this with minus 2, then what you will be getting? This will also be multiplied with minus 2. So, this value will become minus 2 only. Understandable? So, the area is representing minus 2. Area is minus 2. Is that clear to you? So, these are the graphs that we have drawn. Very, very simple graphs. Okay. Let's go to the next topic. So, this is a very interesting thing. Very basic mathematics, that if d by dx fx is given, which is equals to gx, then what will be the value of then what will be the value of fx? Then you need to find out fx. Then what will be the value of fx? Like basically, we need to take this differentiation this side. So, you know that, sir, if differentiation goes to the other side, no, then it will become integration. So, sir, this will be the answer. Is that correct? No. This is wrong. If differentiation is going towards this side, then sir, this is what you will be getting. Is that correct? No. If d by dx is going to the other side, no, then integration will be there, but you need to put the limit as well. Limit will be going from minus infinity to x. Are you able to understand this point? But still it is wrong. Why it is wrong? If I am solving this integration 2 to x dot dx, does it make sense? Basically, you are integrating with respect to x. You are integrating with respect to x, and you are putting the limit of x only. Like basically, if I say x dot dx equals to from 1 to 2, what does that mean? That means, sir, you need to integrate. Let's say this is x square. So you need to integrate x square with respect to x, and then you put the limit of x going from 1 to 2. So similarly, you need to integrate x square with respect to x. The limit of x is going from x equals to 2 to x equals to x. Does this make any sense? Are you able to understand this point? That x is going from 2 to x equals to x. What is x equals to x? And even if you solve this integration, what is the answer you will be getting? Let's just say, sir, I solved it. So answer is x to the power 3 divided by 3. Then x will go from 2 to x. So now you are putting in place of x, you are putting x only. Does that make any sense? No. Right? So in place of x, what I need to replace? In place of x, I need to replace u or any other variable. So now this will make sense. That you need to integrate u square with respect to u, and the limit of u is going from 2 to x. This will make sense. So now answer I will be getting u cube by 3 going from 2 to x. So x cube by 3 minus 2 cube by 3. This would be the answer. So similarly, what you understood from here, that sir, if this is the scenario that is given, d by ds fx, so sir, if I need to write down fx, then what I will do? Sir, d by dx is going this side, then d by dx would be changed to minus infinity to x. Basically, if a plus goes this side, it will become minus. If minus goes this side, it will become plus. If multiplication goes this side, it becomes a division, right? And if division goes to the other side, it becomes a multiplication. If square goes to the other side, it becomes a under root. Similarly, if d by dx goes to the other side, it becomes a minus infinity to x. This is a problem that a lot of people face. They directly put it will become integration. No, it will become integration with the limit minus infinity to x. Now, since you are putting the limit of x, here you cannot put the variable x, so you need to put g of u du. So this will be the value of your fx. Is that clear to you? This is the value of your fx. Understandable? Now, let's do one more thing. In this expression only, this is the answer that we have got. In this expression only, let's put x equals to 0. If I put x equals to 0, what I will be getting? Sir, f of 0 will be nothing but minus infinity to 0 g of u dot du. Right? This is your f of 0. Let's keep this as equation 1 and this as equation 2. Now what I can do from equation 1, what I am doing? What is your fx? Sir, fx is nothing but minus infinity to x g of u dot du. So sir, what I am doing now? Sir, can I break the limit from minus infinity to 0 g of u du, from minus infinity to 0 g of u du, plus from 0 to x g of u du. Say yes or no. Can I break the limit like this? From minus infinity to 0, then from 0 to x. Now what is this? Minus infinity to 0 g of u du. What is this? That is nothing but f of 0 only. So what you are getting from here, let's add another page. So what you are getting, fx is coming out to be f of 0 plus this is nothing but f of 0 only, right? This is nothing but f of 0 only. You see the equation 2, minus infinity to 0 g of u du, that is f of 0 only, plus 0 to x g of u du. This is another answer that you are getting. This was the first answer, this is another answer. Let's just say I put x equals to 1, or let's just say I put x equals to x naught. I am putting x equals to x naught. So from equation 1, if I put x equals to x naught, here I need to put x equals to x naught. From equation 1. So x equals to x naught I need to put. In place of x, I need to put x naught. In place of x, I need to put x naught. So from minus infinity to x naught, g of u du. G of u du. Is that understandable to you? Let's just call it equation 3. Now again from equation 1, what was your fx? Sir, fx was nothing but minus infinity to x fx of gu dot du. Sorry guys, this is a blunder from my end. This was your fx, right? Minus infinity to x gu dot du. This was your fx. Now what do I do? Can I break it somewhat like this? Minus infinity to x naught g of u du plus x naught to x g of u du. Now what is this? This is nothing but f of x naught only. So what I can see, f of x is coming out to be equals to f of x naught. This is f of x naught plus x naught to x g of u du. Another answer. So what did you understand from here? Let's write down the conclusion. The conclusion is that sir, if d by dx fx is given as gx, if d by dx fx is given as gx, then sir, from here what I can see, fx will be nothing but minus infinity, this d by dx goes this side, so it will become minus infinity to x g of u du. So this is the first answer. Now sir, for any random x naught, you can break it like this. For any random x naught, this is your fx only. What you can do, you can break it in this manner: minus infinity to x naught g of u du plus x naught to x g of u du. This is how I can break it. Now what this would represent? Sir, in this equation, if you put x naught in place of x, if you put x naught, then this would represent nothing but x naught only, f of x naught only. So sir, f of x equals to f of x naught plus x naught to x g of u du. There you go. This will be the answer. This is the answer that you will be getting. Is that understandable to you? So if d by dx into fx equals to, sorry, d by dx into fx, I should not say, if d by dx fx is given which is equals to gx, then can you find out fx? Yes sir, this is the first expression that I will be getting. Then I can break it in this manner. Okay, at a lot of places you would have seen this expression, but how this expression came, it would have come from this expression. That fx would be written as integration goes this side, it will, sorry, differentiation goes the other side, it will become integration, but with the limit minus infinity to x. Then I can break it in this manner, that in place of x if I put 0, then this is f of 0 I am getting now from equation 1. So I can break it in this manner. This is my f of 0. So fx is equals to f of 0 plus 0 to x g of u du. Now if I break it at some random x naught, then this is how I can break it. F of x naught in two parts I am breaking it, and now this is how I am getting it. So f of x is equals to f of x naught. F of x equals to f of x naught plus from x naught to x g of u du. Understandable? So this is the meaning of differentiation integration that we have understood. You need to differentiate this graph. You need to differentiate this graph and you need to draw the graph of gx. Like differentiation of this graph is nothing but gx only. So differentiate this graph. This is the question, that you need to differentiate this graph. You need to differentiate this graph. So what is the slope here? What is the slope here? 0. How the slope is 0? Because sir, if x is increasing, the y is not changing at all. What is the meaning of slope? What is the meaning of slope? Slope is nothing but differentiation. Slope is nothing but differentiation. Differentiation has simple meaning, that is slope. Okay, and what is the meaning of slope? As x changes, how much your y is changing. So x is changing but y is not even changing, that means slope is 0 here. What is the slope here? Just one second. Yeah, so let me know what is the slope here. Sir, x is going from minus 2 to 0. That means x is increasing, minus 2 to 0. X is increasing by 2. What is happening with y? Y is going from 2 to 0. That means y is decreasing by 2. Y is decreasing by 2. So what is the slope? Slope is minus 1. What is the slope here? Slope is plus 1 here. If x is increasing from 0 to 2, that means x is increasing by 2, and y is increasing from 0 to 2 as well. So y is also increasing by 2. So 2 by 2, slope is 1. And what is the slope here? Slope is minus 1 here. Understandable? So what did you, and after that, what is the slope? If x increases, then y is not even increasing. So slope is 0 only. X is increasing, x is going from 4 to 5 to 6, but y remains always 0 only. So what is the slope? That is 0. So slope is 0 initially till the point of minus 2. Till the point of minus 2, then it is 0, then it is plus 2, then it is plus 4. So till the point from minus infinity to minus 2, the slope is 0. Then the slope is minus 1. Then the slope is plus 1. Then the slope is minus 1. Then the slope is 0. This is the scenario. And I told you in mathematics, this is how we can show it. That slope is going from 0 to minus 1, then from minus 1 to plus 1, then from plus 1 to 0, then from 0 to, from plus 1 to minus 1, then from minus 1 to 0. This is how we can draw the graph. So slope here was 0, this slope was, this amplitude is 0, this amplitude is minus 1, this amplitude is plus 1, and this amplitude is minus 1. So this is how you can draw the graph. Okay, so and it is a straight line, although it is looking like not a straight line. It should be a straight line like this. Okay, it is a straight line. Okay, so value here is 0, then minus 1, then plus 1, then minus 1, and then again the value is 0. So this is how the graph of differentiation will look like. You are differentiating the graph. How you are differentiating? Differentiation, simply the meaning of differentiation is slope, nothing else. The meaning of differentiation is slope, nothing else. So now you need to differentiate ux. When you differentiate ux, what you will be getting? Think about it and let me know what you will be getting when you differentiate ux. What is the slope here? The slope is 0. And what is the slope here? Sir, as x increases, the y remains the same only. Y is always 1. Like at x equals to 1, what is the value of y? That is also 1. At x equals to 2, what is the value of y? That is 1. At x equals to 3, what is the value of y? That is 1 only. So if x is increasing, y is not increasing. So sir, here also the slope is 0. The slope is 0 here, slope is also 0 here. So sir, if I draw the graph, then sir, slope is 0. Here slope is 0, and here also the slope is 0 only. But you let me know one thing. What is the slope at x equals to 0? Slope at x equals to 0. Slope at x equals to 0. So you need to find out d by dx ux at x equals to 0 you are finding out. So you let me know. X is going from 0 minus to 0 plus. How much x is changing? X is changing by 0. X is changing by 0. But how much y is changing? Y is going from 0 to 1. Y is going from 0 to 1. From 0 minus to 0 plus, x is changing by 0. 0 minus means just before 0. 0 plus means just before 0. So what is the gap between them? That is 0 only. So x is changing by 0, but how much y is changing? Y is going from 0 to 1. Do you understand what is the meaning of y? This I am calling as y. This I am calling as y. fx, this I am calling as y. So how much y is changing? Y is going from 0 to 1. So y is changing by 1. So what is the slope? Slope is infinity. And in the electronics, or I should say in engineering mathematics, what is the meaning of infinity? Infinity means the amplitude is infinity. What does that mean? It is impulse. So there will be an impulse of area 1. There will be an impulse of area 1. Why is that so? Because there is a jump of 1, no? If there was a jump of 2, then the area would have been 2 here. Let's just say in place of 1, if it was 2, then it would have been 2 by 0. So I would write down that amplitude is infinity. There will be impulse, but with the area of 2. So here how much jump is there? There is a jump of 1. Jump of 1. So what will be the differentiation? That will be 1 only. Is that understandable to you? So this is the differentiation. So this is the differentiation which is fx. Okay, this is not fx. The differentiation is fx, no? So let's not make it fx. So this will be the differentiation fx. Is that clear to you? So this is your d by dx of ux. So what did you understand? So d by dx of ux is giving us delta x. So let me make a graph and you let me know what will be the differentiation of that. What I am doing, I am making a graph for you. You need to differentiate that particular graph. Simple differentiation, not difficult at all. You just need to differentiate that graph. Let us say value is 0 here, then the value, then sudden drop, okay. So what is the slope here? You need to differentiate this graph. This is your fx, you need to differentiate this. What we are doing, we are differentiating it now. What we need to do, we need to differentiate it. So d by dx of fx, we need to differentiate. What we will get? We will get gx. So we need to differentiate. So what is the slope here? The slope is 0. What is the slope here? Sir, x increases by 1, y increases by 2. X increases by 1, y increases by 2. So sir, the slope is 2 only. The slope is 2 only. X increases by 1, y is increases by 2. What is the slope here? Sir, x increases by 3, but y is not even increasing. Y remains the same, which is equals to minus 2. Slope is 0. What is the slope here? Sir, x increases by 1, y also increases by 1. So slope is 1. What is the slope here? Sir, x increases by 2. X increases by 2. But sir, y decreases by 3. Y decreases by 3. So slope is minus 3 by 2. Right? Is that understandable to you? Slope is minus 3 by 2. No? Y decreases by 3. X increases by 2. So slope is minus 3 by 2. Understandable? These are the slopes. But important part is, one more important part is there that we will see when we draw the graph. So now I am drawing the graph of differentiation. So let's see it. Till this point, till minus 3, what is the slope? The slope is 0. Till minus 3, the slope is 0. Then from minus 3 to minus 2, what is the slope? From minus 3 to minus 2, what is the slope? The slope is 2. Slope is constant, which is 2. Slope is constant, which is 2. Then from minus 2 to 1, what is the slope? Minus 2 to 1, the slope is 0. Minus 2 to 1, the slope is 0. From minus 2 to 1, the slope has become 0. Now, have I missed anything? Is this correct or did I miss anything? Sir, there is a drop as well, no? There is a drop in the graph. The value is going from 2 to minus 2. So, there is a drop of 4. So, slope at x equals to minus 2. Slope at x equals to minus 2. Slope at x equals to minus 2. What will be the slope? The slope will be slope at x equals to minus 2. So d by dx fx, what that would be? Sir, change in x is 0 only. From minus 2, minus 2, minus 2 plus. Change is 0. But how much y is changing? Y is changing from 2 to minus 2. That means y is changing by minus 4. No. It is going from 2 to minus 2. That means what is the change? Change is minus 4. That means, sir, amplitude will be minus infinity, but the area will be minus 4. That means here, whatever that I showed, here whatever that this line I showed, I should show in this manner. I should show in this manner, looking downward, that there will be impulse as well with the area of minus 4. Is that understandable to you? This is how I need to show. Now, sir, from 1 to 2, what is the slope? From 1 to 2, the slope is 1. From 1 to 2, the slope is 1. From 1 to 2, the slope is 1. But what is happening at 1? Sir, what is happening at 1? The graph is going from minus 2 to plus 2. So, slope at x equals to minus 1. slope at x equals to minus 1. What will be the slope at x equals to minus 1? Sir, x is changing by 0, but the graph is going from minus 2 to plus 2. So the slope will be infinity. Slope will be infinity. Slope will be infinity. How do we show infinity in the mathematics? By the impulse. But what will be the area? Area will be 4. What this area is representing? This area is representing that you are taking a jump of 4. Here you are taking a decay of 4. You are taking a jump of 4 but in downward. Here you are taking a jump of 4 but upward. Now someone would say that, sir, if I walk from here to here, then I would say that, sir, there is a jump of 4 downward. Like someone would say that, sir, if I am coming from here to here, then I would say that, sir, it is coming down. But always I have told one thing, that whenever you do integration or differentiation, you always start your journey from minus infinity. Always you will start the journey from minus infinity. So you are starting from minus infinity. In application of derivative, we have studied, no, like someone would say this graph is increasing, right? Because he is seeing from here, the graph is increasing. What if someone would say that, sir, I am looking from this side, the graph is decreasing? But from where you would look? You would always look from the left hand side. From the left hand side, if I see the graph is increasing, so you never look from right hand side, you always look from left hand side. Always look from left hand side. So always I will see the slope from left hand side. Slope equals to 0. Is there any sudden jump? No sudden jump is there. Here there is no sudden jump. Smooth graph. Slope is 2. Then is there any sudden jump? Yes. You are going from 2 to minus 2. There is a sudden jump. 2 to minus 2. So there is a jump of 4. So what will be the differentiation here? Differentiation will be infinity, but the area will be minus 4. Then is there any sudden jump here between all these points? No sudden jump. Slope is 0. Then again there is a sudden jump. The slope is infinity, but the area is 4. Now what is the slope here? Slope is 1. Now is there any sudden jump at x equals to 2? At x equals to 2, is there any sudden jump? No, it is going down slowly. Here it is the sudden jump. No, directly it is falling down. Here also there is a sudden jump. Directly it is taking a jump. But here it is falling down slowly. So there is no sudden jump. So between 2 to 4, what is the slope? Between 2 to 4, the slope is minus 3 by 2. So between 2 to 4, the slope is minus 3 by 2. Slope is minus 3 by 2. And then from 4 to 0, the slope is 0. Then from 4 to 0, the slope is 0. Here this value was 2, this value was 0, this value was also, slope was 1 only, no? Between 1 to 2, the slope was 1. So what I need to do is that the slope was 1. And here what is the slope? The slope is minus 3 by 2. Okay. Understandable? This is your gx versus x. So between minus 3 to minus 2, the slope is 2. Between minus 2 to 0, the slope is 0. Between 0 to 1, the slope is 0. Between 1 to 2, the slope is 1. Between 2 to 4, the slope is minus 3 by 2. Between 4 to infinity, the slope is 0. Right? Then there are sudden jumps. Here there is a sudden jump. Here there is a sudden jump. So these two sudden jumps are there with the area of minus 4, with the area of plus 4. These are the sudden jumps. So this is how you will differentiate the graph. Is that clear to you? So this is the differentiation of the graph. Understandable? Well and good. Let's go to the next one. You need to differentiate dy dx to u of x plus 1. Either you draw the graph, then you differentiate, or you can differentiate. dy dx of 2 u of x plus 1. So 2 you take outside, dy dx of u x plus 1. Now do you know one thing? What is the differentiation of ux? The differentiation of ux is nothing but delta x. So similarly, what will be the differentiation of u of x plus 1? So that will be nothing but delta of x plus 1. There you go. This is the answer. Or you can go by the graph as well. How will you go by the graph? Can you draw the graph of 2u of x plus 1? 2u of x plus 1. U of x, this is the graph of u of x. U of x plus 1. X plus 1 means it will be shifted by 1 here. It will be shifted by 1 here. And then multiply with 2. So what kind of graph you will be getting? This kind of graph I will be getting. 2u of x plus 1. 2u of x plus 1 minus 1. So this is the graph of x you are getting. Right? Now you need to differentiate. Now you need to differentiate. Now you need to differentiate. differentiation I am showing by f dash x. So what you will see, what is the slope here? The slope is 0 here. What is the slope here? Here also the slope is 0. But sir, here you can see there is a sudden jump of 2. So at x equals to -1, there is a sudden jump of 2. So what is the slope here? Slope is 0. After that as well, there is a slope which is 0. But sir, here there is a jump of 2. How much jump is there? From 0 to 2 you are going. From 0 to 2 you are going, no? So what is the jump? Jump is of 2. The jump is of 2. Jump is of 2. Jump is of 2. Jump is of 2. So what is the answer? 2 delta of x plus 1. What is the differentiation? From here to here, what is the differentiation? Here the value was 2u of x plus 1. 2u of x plus 1. And if I differentiate, the answer is 2 delta of x plus 1. This is the answer. From 2u x plus 1 to differentiation 2 delta of x plus 1. Understandable? Is that clear to you? Okay. So this is how you can do it. With the mathematics also you can do it. You should know how to solve with respect to graph as well. Like this kind of differentiation you should know. That here there is 0, then what is the differentiation here? Slope is 2. Here what is the differentiation? Slope is -4. Here the slope is infinity, but area is -4. Here the slope is 0. Area is +4. Slope is infinity only. Here the slope is 1. Here the slope is -3/2, and so on. Similar scenario is available here as well. Okay. Solve all this question. If d by dx ux equals to delta x, this you already know, no? D by dx ux equals to delta x. Where we have seen it? Here we have seen it. That d by dx ux equals to delta x. Then what will be the value of ux? What we have shown, what we have seen, d by dx of fx equals to gx. So what will be the value of fx? So that will be nothing but -infinity to x g of u du. So similarly, from here, what will be the value of ux? The value of ux will be -infinity to x delta of u dot du. So here I should write down -infinity to x delta of u dot du. That is equals to, what that would be equals to? That would be equals to ux. So when you differentiate step, you get impulse. And when you integrate impulse, what do you get? You get step. When you integrate impulse, you get step. Say yes or no. Understandable? Clear? Now sir, but this we have seen that is equals to 1. So yes, this is equals to 1 only. There are constant limits. No, this is the limit of x. Here the limit of x is there. So answer will be in terms of x only. But these are the constant limit. When you integrate from -infinity to infinity, this is representing the area of the impulse. This is representing the area of impulse. Area of impulse. This is simply representing this graph. Only x-axis I am making, and at x equals to 0, you are having an impulse. At x equals to 0, you are having an impulse of area 1. So this is what it is representing. Are you able to understand this point? Say yes or no. Right? So here both of the limits are constant. If both of the limits are constant, then you will get a constant answer. Here one limit is constant, another limit is variable. So you will get a variable answer. What will be 3 -infinity to infinity delta x? So 3 I can take outside. -infinity to infinity delta x dot dx. What will be the answer? Answer will be 3. So again, you are having an impulse at x equals to 0 with the amplitude of infinity, but the area of 3. This was your delta x. This was your 3 delta x. Now what about 2 of delta x minus 1? 2 of delta x minus 1. Delta of x minus 1. X minus 1 means delta x will be shifted by 1 towards the right hand side. So this will be your delta of x minus 1. Look, this is the graph of delta of x minus 1. This is the graph of delta of x minus 1. But you need to multiply it with 2. You need to multiply with 2. So area will be 2 only. So what you are integrating? You are integrating from -infinity to infinity. You are integrating from -infinity to infinity. So -infinity to infinity you are integrating. What is the area you will be getting? That will be 2 only. Understandable? Next question. -4 delta of x plus 1. Delta of x plus 1. Delta of x plus 1 means there will be impulse at x equals to -1. Basically here the impulse will be here the impulse was at x equals to 1. How did you know? That sir, you put the inner side equals to 0. So what you are getting, x equals to 1, x minus 1 put equals to 0, x equals to 1. That means there will be impulse at x equals to 1. So similarly, what I would do here, so whatever that is inside, I will put that equals to 0. So at x equals to minus 1 I am getting. So at x equals to minus 1 I am having an impulse of area minus 4. I am having an impulse of area minus 4. That means I need to make an impulse of area minus 4. Impulse of area minus 4 at x equals to minus 1. Okay. So you need to integrate from minus infinity to plus 2. From minus infinity to plus 2. This is your x equals to 2. So you need to integrate from minus infinity to plus 2. Minus infinity to plus 2. So is the impulse coming? Yes, impulse is coming into action. Answer will be minus 4. What is the total area? Total area will be minus 4. What about 3 delta of x of minus 3? 3 delta of x minus 3. Where will be the impulse? The impulse will be there at x equals to 3. Impulse will be there at x equals to 3. Impulse will be there at x equals to 3. And what is the amplitude? Amplitude is 3. Amplitude is 3. Amplitude is 3. You need to integrate from x equals to minus infinity to minus 1. You need to integrate from x equals to minus infinity to minus 1. In this much area you need to integrate. From minus infinity to minus 1. You need to integrate from minus infinity to minus 1. Is the impulse coming into action? No, impulse is not even coming into action. Answer is 0. Why the answer is 0? Because you are integrating from minus infinity to minus 1 only, no? The impulse is coming into action at x equals to 3. The impulse is coming into action at x equals to 3. And it is not even there in this limit. It is not even there. Here the impulse is coming into action at x equals to minus 1. It is there in the limit? Yes, sir, it is there. Here the impulse is coming into action at x equals to 0. It is there in the limit? Yes, it is there. Impulse is coming into action at x equals to 0. It is there in the limit? Yes, it is there. Impulse is coming into action at x equals to 1. It is there in the limit? Yes, it is there. Yes, it is there in the limit. So similarly, here x equals to 3. Is it there in the limit? It is not even there in the limit. You are integrating from minus infinity to minus 1 only. So what will be the answer? Answer will be 0. Is that clear to you? Okay. So this we have seen. Next, what we need to see, what will be the differentiation of Rx? What will be the differentiation of Rx? Very, very simple concept, very, very straightforward. Can you draw the graph of Rx? Absolutely, sir. I can draw the graph of Rx. Here, what is the value? Rx means simply, sir, for x less than 0, the value will be 0. And sir, for x greater than 0, the value will be equals to x. So this will be fx equals to 0. And here, fx equals to x. This is your Rx. This is your Rx graph. Right? R of x versus x. This is your R of x versus x. R of x versus x. Okay? R of x versus x. So what is the slope here? The slope is 0. And what is the slope here? The slope is 1. So you need to differentiate. When you differentiate, first of all, you let me know, is there any sudden jump? Absolutely not. There is no sudden jump. There is no sudden jump. Right? So if you differentiate, what you are getting? If you differentiate, what you are getting? If you differentiate d by dx of Rx. For x less than 0, the value is 0 only. Here the value is 0 only. For x greater than 0, the slope is 1. So what is the answer? This value is 0. Here the slope is 1. So what this is becoming? This is becoming ux only. For x less than 0, the slope is 0. For x greater than 0, the slope is 1. So what is this? This is ux only. So what did you understand? The differentiation of Rx is nothing but ux. D by dx of Rx is nothing but ux. D by dx of Rx is nothing but ux. That's it. So what you need to see from here? That sir, if I differentiate delta x, if I integrate delta x, what we have seen? D by dx of ux. What was the answer? Delta x. And d by dx of Rx also we have seen. What is the answer? That is ux. From here, if I see, ux will be equals to minus infinity to x delta of u du. And from here if I see, r of x will be equals to minus infinity to x, u of u will be looking a bit different. So I should say u of alpha d alpha. I just need to introduce another variable, no? So I'm just introducing another variable. Understandable? So what you understood? That sir, if I integrate this, I will get ux. And if I integrate ux, I will get rx. Sir, if I differentiate rx, then I will get ux. And sir, if I differentiate ux, I will get delta x. Understandable? Is that clear to you? So these are the scenarios that you need to remember. You don't need to remember, it is very simple. Ux graph you already know, differentiation of ux will be delta x only. This you can write down very easily. Differentiation of rx graph you already know what will be the differentiation, that will be ux only, and then you can write down all these things. So this is the final conclusion that should be remembered. Now what you need to do? You need to integrate minus infinity to x ru du. This is what you are supposed to do. So ru du. Can I write down ru as u into du? Sorry, u into ru could be written as, let's keep as alpha. Okay, this is what you need to do. R of alpha d alpha. Now can you let me know what was your rx? Sir, rx was written as x into ux. Say yes or no? Rx was x into ux. This was your ux. This was the graph of x. You multiply both of them, what you will be getting? This graph only. If you multiply both of them, so this graph you will be getting. So this was ux and this was x. So rx was x into ux. Rx was x into ux. So what will be your r alpha? R alpha will be alpha into u alpha. So can I write down fx as minus infinity to x alpha into u of alpha d alpha. Now you know one thing, that sir, if I draw the graph, if there is something called u, if u of alpha is coming, that means if I draw the graph of r alpha, then from where it will be starting? If I draw the graph of r alpha, sir, the graph will be starting from 0 only, no? Like from minus infinity to 0, what will be the result? The result will be, from, if I integrate from minus infinity to 0, the result will be 0 only. After 0 to x, let's just say x is somewhere here. So from 0 to x, whatever the result I will get, the same result I will get from minus infinity to x as well. What I mean to say is that minus infinity to x, let's just say this graph is, what is this graph? R of alpha. R of alpha with respect to alpha. So minus infinity to x, r of alpha d alpha would be equivalent to 0 to x r of alpha d alpha. Do you agree to this point or not? Because sir, the integration between minus infinity to 0, that will be 0 only, because there is no area here. The area is 0 only. So sir, if you integrate from minus infinity to x or you integrate from 0 to x, both will give you the same result. But the condition is that x has to be greater than 0. You assumed x here, no. X could be here as well. So here you will say that sir, both are equal, but if x is greater than 0. So here what I can say, that fx could be written as, sir, between minus infinity to 0, I will get 0 answer only. So fx could be written as integration going from 0 to x alpha d alpha. Because you are eventually integrating this graph. What is this graph? R alpha equals to alpha only. So I am integrating this graph only. So I can write down fx equals to 0 to x alpha dot d alpha with the condition that x is greater than 0. Is that understandable to you or not? Is this particular scenario is understandable to you or not? Is this scenario understandable or not? So just draw the graph of R alpha. If I draw the graph of R alpha, I go to know that for alpha less than 0, there is nothing. For alpha greater than 0, yes, the graph is equals to alpha. So for alpha less than 0, there is nothing. That means minus infinity to 0 will throw everything 0 only. So I can take the limit from 0 to x. Now x has to be greater than 0. X has to be greater than 0. X has to be greater than 0. So from 0 to x, R alpha d alpha. Now what is the value of R alpha? Value of R alpha is equals to alpha only. So here you put alpha. So this is what you are getting. Fx equals to what you are getting. Alpha dot d alpha will give you alpha square by 2. And the limit is going from 0 to x. So from here, fx you are getting, that is x square by 2. But this is the answer when x is greater than 0. So what is the answer of fx? answer of fx is x square by 2 when x is greater than 0. So let me add another page. The scenario was that you are integrating this particular function. Everything is 0, 0, 0 here, and then this is the scenario. And now when you are integrating this particular function, here the value is 0, here this value, let's just say this was your rx. So when you integrate this, this graph was equals to x only, no? Here rx equals to x, here rx was 0, here rx was equals to 0, and here rx equals to x. So when you integrate this, integrating with the limit minus infinity to x. So when you integrate this, what you are getting? Value is 0, 0, 0, value is 0, 0, 0, 0, 0 here, and then integration of this will be like this. Okay, so this is your the integration was x here, so this became x square by 2. So this is your integration of minus infinity to x r of alpha d alpha. This is the integration that I am showing. Understandable? So integration will become x square by 2 for x greater than 0. For x less than 0, the value will be 0 only. Is that understandable to you? So minus infinity to x r alpha dot d alpha, the result was 0 if x is less than 0, and if x is greater than or equals to 0, then the result is x square by 2. So can I write down this function as, x square by 2 ux? Say yes or no. X square by 2 ux. Think about it and let me know. Quickly let me know, is this correct? Yes sir. For x greater than or equals to 0, it is x square by 2. For x less than 0, it is 0 only. Basically, this is the graph. What is the graph of x square by 2? This is the graph of x square by 2. Multiply with ux. If you multiply both of them, this multiply with 0 will be 0 only. This multiply with 1 will be this graph only. So x square by 2 ux. Understandable? So this is how we can write it down. So this is the integration. Is that clear to you? Okay. So basic integration differentiation we can see. Now can you integrate this graph? Which graph? Can you integrate this graph? Can you integrate this graph? This is your fx. You need to integrate this graph now. Let's just say this value is 2, whatever it is, this value is minus 1, this value is minus 1. You need to integrate this now. Integrate this. What will be the integration of this? You will be starting the integration from minus infinity to till a random x. So let's just say, sir, I integrated from minus infinity to minus 1. So till this point, sir, there is no area, answer will be 0 only. Now, sir, I started getting some area, right? From minus, after minus 1, I started getting some area. And isn't it like ramp only? Isn't it like ramp only? Yes, it is like ramp only, no? It's like ramp only. And what is the integration of ramp? That will be in this way, parabolic way. So, sir, the graph will increase like this. The graph will increase like this. So area will keep on increasing. If I am going from minus 1 to 1, the area will keep on increasing. No, sir, initially this much area is there, then sir this much area is there, then sir area will increase more, then sir this much area would be there, then sir area will increase more, and eventually till this point the area would increase. Basically, if I ask you what is the integration from minus infinity to minus 1 fx dx, sir, what is the area? Area is 0. If I ask you what is the integration from minus infinity to 0 fx dx, how much is the area? So this area is half into base into height, the area is 1. If I ask you what is the integration from minus infinity to 1 fx dot dx, so what is the total area? So this area half into base into height, so total area will become 2. If I ask you what is the integration from minus infinity to 2 fx dot dx, so between minus infinity to plus 2, how much is the area? The area is, sir, 2 only. If I ask you what is the integration from minus infinity to 3 fx dot dx, or let's write down 100 here. So how much is the area between minus infinity to 200? So the area is 2 only. And if I ask you what is the area here, that is sir 2 only. So the area increases in this range from 1, it increases from here, it goes from 0 to 2, and after that it remains constant always. So this is the value of x. No, this is the value of x. You are integrating from minus infinity to x. When the value of x was minus 1, the area was 0. When the value of x is 0, the area has become 1. So this value is 1. When the value of x is 1, the area has become 2. When the value of x is 1, the area has become 2, and the graph will be rising in this exponential way, right? And after that, what will happen? The area will always remain 1 only. The area will always remain 2 only. So this is how the graph would go. Is that understandable to you or not? So let's make this portion in a bit better manner. In the parabolic way, it will rise. In this way, it will rise, and then it will remain at 1. So this point is 1, and this point is 2. There you go. This is the graph. Is that clear to you or not? Say yes or no. Surely, sir, it is completely understandable to me. Well and good. Okay. So this is the graph that you will be getting. Area is 0, the area becomes 1 here, then area becomes 2 here, then it remains constant. After that, it remains constant. Understandable? Okay, so this is the meaning of integration. Now the value of x is given, the value of fx is given, and you need to draw the graph. You need to draw the graph, and fx is 0 for all other value of x. You need to draw the graph of fx. So how will I draw this graph? Very simple thing, although these kind of things we study in class 5th, 6th, but still I am writing down. So this is how I will draw the graph. Only discrete values are there, no? Only discrete. They are known as discrete values. That means x is not taking any value minus 3 by 2. Not any random value it is taking. X is taking value minus 2. X is taking value minus 2. Let's say this is your minus 2. X is taking value minus 1. X is taking value 0. X is taking value 1. X is taking value 2. X is taking value 3. It may take value 4 as well, but all these values are 0, that I don't care. So at x equals to minus 2, what is the value? So this is how you will be showing it. At x equals to minus 2, so the value is 1 by 2. At x equals to minus 2, so the value is 1 by 2. At x equals to minus 1, the value is 0. At x equals to 0, so the value is 1. The value is 1. At x equals to 1, the value is minus 2. At x equals to 1, the value is minus 2. At x equals to 2, the value is 0. At x equals to 3, the value is 3 by 2. The value is 3 by 2. So this is how we will be showing fx. Okay. Discrete values, this is how they are shown. Now if fx equals to x square, then how do we show it? This is how we make the graph. Continuous graph we make. But these are the discrete values, no? So we will make the discrete graph in this manner. Okay. Only some particular values we know. X can take value minus 2, minus 1, 0, 1, 2, 3. Because next we are going to study about random variable, no? So a random variable will be a variable only. A variable x. So this variable x could take values like x equals to 0, x equals to minus 1, x equals to minus 2, x equals to 4. So this random variable x could take these values. So it may take discrete values as well, or it might happen that the random variable x is taking all the values between 0 to 5. It can take all the values. It can take 0.000000001 as well. It can take 0.00002 as well. So this is known as discrete random variable. Discrete random variable because it is taking discrete values only. And this is known as continuous random variable because it is taking all the continuous value between 0 to 5. So that's why sometimes I will draw the graph like this as well. Okay. This kind of graph also we will draw sometimes. So that's why you should be habitual with this graph as well. Till this point, when we are studying calculus or whatever the subject you have studied, you are drawing continuous graph only, but you should have the habit of drawing the discrete graph as well. Okay, you in class 5th, 6th, when we were introduced to graphing, then initially we used to draw these kind of graphs only, right? When we were getting the introduction to graph. So initially we started like this. Do you remember that? We used to bring a graph paper, then we used to draw this kind of graphs, right? Right? In that manner we used to draw the graph, although there was only positive values. So the same thing we have drawn here. Now, what is the way of representing this graph? Like how I can write it down? What I mean to say is that, let's just say you solved a particular question and this graph is your answer. You solved a particular question and this graph is your answer. This is your answer. But in the examination, fx is mentioned like this. In the options, fx is mentioned like this. First of all, you let me know, is this impulse? No, this is not impulse. This is amplitude, right? This is amplitude. 1 by 2 is the amplitude. So is this impulse? No. This is not impulse. This is also amplitude. All these are amplitudes. So this is not impulse. So if I say that I am having an impulse of 1 by 2 at x equals to minus 2, that would be wrong, right? If I say I am having impulse of 1 by 2 at x equals to minus 2, this thing is wrong. But if I need to show this function, then how will I show it? Sir, impulse of 1 by 2, impulse of area 1 by 2 at x equals to minus 2, at x equals to minus 2. Why I am showing x plus 2? Because sir, if I put x plus 2 equals to 0, then I will get x equals to minus 2. That means I am having an impulse at x equals to minus 2 with the area 1 by 2. So this is how I will be showing it. If I say impulse, if I need to show, then how I will be showing it? I will be showing in this manner. The impulse, sir, I will be showing in this manner, that x equals to minus 2, at x equals to minus 2, I am having an impulse of area 1 by 2. This is how I should be showing it, sir. This should be the way. But sir, this is not impulse, this is the amplitude. But sometimes what happens is that in the examination, this is your answer, this is the answer that you have got. This is the answer that you have got. But in the examination, what will be mentioned? It will be mentioned as impulse. That means 1 by 2 delta of x plus 2. Plus, sir, I am having an impulse of area 1. Although it is not area, it is the amplitude at x equals to 0. I am having an impulse of area minus 2. Although it is not area, sir, it is amplitude at x equals to plus 1. So it could be written as x of minus 1, because this will show the impulse at x equals to plus 1. And plus 3 by 2 delta of x minus 3. This is how it could be shown in the answers in the examination hall. Although you can argue here that, sir, these are not impulses, these are not impulses, these are the amplitude, these are not the area. You can argue that. But sir, I solved a particular question and I am getting this particular answer. I am getting this particular answer. I am getting this answer. I am getting this waveform as my answer. Now what I will do? In the examination, will I argue that, sir, these are the impulses? So you cannot show like this. No. What I will see? I will treat them as impulses only. I will treat them as impulses only. In my mind, I know that they are not impulses. In my mind, I know they are not impulses. But in the examination hall, I will treat them as impulses and I will write down the function. What I am having an impulse of area 1 by 2 at x equals to minus 2. So 1 by 2 delta x plus 2 plus delta x plus minus 2 delta of x minus 1, because you are having an impulse at x equals to 1. Then you are having an impulse at x equals to 3. So plus 3 by 2 delta of x minus 3. This would be the answer. So sometimes in the examination this could be mentioned, and it has been mentioned a lot of times as well. Okay. So there we will not argue. We will simply say that yes, this is how we can represent, and that would be the answer. More than 5 to 6 times this has happened. So if you are getting this answer, this waveform as your answer, sir, this is my answer, how will I represent? This is how you will represent. Area of impulse 1 by 2 at x equals to minus 2, area of impulse 1 at x equals to 0, area of impulse of area minus 2 at x equals to 1, impulse of area 3 by 2 at x equals to 3. Understandable? So this is the end of your prerequisites. I thought that it will be ending in 50 minutes, but it's been roughly around 100 minutes. So prerequisites have ended in roughly around 100 minutes. Okay. Next, what we need to study? We will study about now random variable. Random variable. Okay then. Now the thing is that this random variable in electronics, in EC, there is a subject called communication system. Communication system. Okay, there is a subject called communication system. Now in communication system, there is a topic called random process. Random process, then digital communication, and then information theory. These are the topics, and then analog communication. These are the 4 chapters. So we start from random process. Without studying random process, you can never understand digital communication. You can never understand information theory. So we start our understanding from random process. Okay. But to understand random process, the knowledge of random variables are required. Now, where do we study random variable? We study random variable in engineering mathematics. But what really happens is that in engineering mathematics, people study random variable on a very surface level. They study on a very surface level. I don't know why. Although it should be studied in depth. In the engineering mathematics only it should be studied in depth, because the complete machine learning or these kind of advanced topic are completely based on random variable. So surely it should be studied in depth. But I don't know why in engineering mathematics we study it on a very surface level. Then when I teach communication system, so I teach this random variable again. So this I have already taught. Okay, on my communication system course, I have already taught random variables. So now what I'm going to do, I'm going to add up the same videos of communication system here. Okay, here, so in this lecture series, I'm going to add up the same videos of a communication system. Sir, I never studied electronics. Will I be able to understand? Absolutely, you will be able to understand. Sir, I'm not from EC. Will I be able to understand? Absolutely. Because when I'm teaching communication system and when I'm teaching random variable there I said one thing that I will teach complete mathematics. So complete random variable has been completed right from 0 to advanced, full. It's not that, sir, you might be teaching it as a prerequisite. No, I did not teach it as a prerequisite. When I was teaching communication system random variable, I taught completely in advance only, from 0 to advance. It was not a prerequisite. I did not say that you should be studying in engineering mathematics, because I know that in the engineering mathematics people have ignored random variable. They have studied on a very surface level. That's why in communication system I have taught it completely in the advanced level only, from 0 to advanced. So here, no matter whether you are from CS, you are from DA, you are from EC, or you are from electrical, or you are from civil, mechanical, or you are from chemical or any other engineering branch, for all of them it will be helpful. So what I will do is that I will add up the videos of communication system only. Because there is no meaning of teaching the same content again and again. Since I already taught, I will add up those same videos. You can study from there. So in the great detail, we are covering from 0 to advanced. We are covering random variable. Is that clear to you? Say yes or no. Understandable? So let's get started studying about random variables. Thank you very much. Happy